Hey, we're back with the Minibot and a upgrade as suggested by one of my viewers. Welcome to Hack-A-Week. So as usual, the comments section on the YouTube video I did last week helped me out. A lot of times I get suggestions from viewers and they turn out to be really good suggestions, as in this one. There's another motor driver available from Pololu. It's called the DRV8835 Dual Motor Driver Carrier. And that's it right there. It's tiny, teeny tiny, a lot smaller than the other one, which was designed to be an Arduino shield. So it's meant to plug into an Arduino on the risers that come off from that. That's why it's as big as it is. This one is the size of half a postage stamp. That's pretty cool, so I can put it on the board. So we're going to pull this one off. We'll use it in another project on an Arduino as a shield, and we'll pull it off and put this one on. Let's see, what else? There was another viewer, I got my page open here, that made a suggestion. Let's see, the guy that suggested this, by the way, Pete, thanks a lot. Shout out to Pete for piping in on that one. Let's see, somebody else, I don't know how to say, YouTube names are weird. Where do people come up with some of these names? Anyway, it's CFAVREAU. I really don't even know how to begin to pronounce that. C. Favreau. Have I got it right? Good guess, I guess. Anyway, he said 5mm LEDs work great for tail dragger robots. So I'm going to pull this little thingy off the back. And I've got some 5mm LEDs. I've got some 10mm LEDs as well. And we'll put one of those on there and maybe we can make it light up. That'll be cool. Just make it blink as it moves, or we could code it in. We can play with that later. But we're going to do a little reworking on the board here, move things a little around, a little. I sure am saying a little a lot. Anyway, let's get to work. So here is the Minibot as we left it off last week. We're going to remove this motor shield and we're going to replace it with this tiny little one here. Let's get that out of the package and see just what it looks like. We'll just slice this open without slicing any flesh. Oh, wait a minute. It's sealed there too. It's a trick package. Alright. And it comes with some header pins. But that's it right there. Look how cute and tiny that is. Fits on my finger. Itty bitty. So, we need to get some header pins soldered to this. Solder, solder, solder. Solder. I like saying that like different ways in each video. Somebody said last week they counted 20 different ways I said it. So anyway, this side has all of the pinout labeling on it. I'm trying to get it here where it doesn't glare in the light. You can see it. It's got everything labeled right here. May not be such a bad idea to mount it with that side up, so that I can see exactly what those pins are. It makes it a little bit easier to work with. And over here on the microcontroller, all of the labeling is also pointing up already, so we're good to go there. So what we need to do now is get this stuff off the board. Okay, let's see, there we go. We've got the microcontroller removed, also have the motor shield removed. And we're going to put this back on somewhere, and we're also going to put the dual motor driver carrier on here somewhere. But we're going to kind of play around with locations here and really think this out this time and decide just where we want these. I've put the header pins on the motor driver so that I can drop that in where I need to. I want to leave room back there for the little LED. Let's see, let's just try putting it, well, Alright, let's think about this for a minute. If we put it all the way to one edge, then we can utilize all of the holes along each side to put wires in and move wires around, jumper wires to different things. And it leaves this area of the board open for future additions to the board. And the motor driver, we could do the same thing with. I could put them as close as that, but a little more room in between them would be nice. And let's see, I've got the grounds on this side. Over on this one, the ground is over here. Might be kind of nice to have the ground near each other. So we could do something like this maybe. Put this here, about there. And let's see, the ground is there. The ground is here on this side. Try to keep things oriented in such a way where the grounds and the powers are on the same end of the board. So right now I've got it set up like that so that the ground and the voltage in VCC is all on this end of the motor driver. And let's see, over here we've got the ground voltages on this end of the microcontroller. So that may work out pretty well right there. I've got this battery pack that in relation to everything else is humongous. And it's got its own little on-off switch, which is pretty neat. It holds two 3-volt batteries. That's going to be a 6-volt power supply. That could go on the board, I suppose, somewhere. Just stick to it. Now, if I was to turn these a little, I suppose we could work that out. Let's just play around with it for a while until we come up with something that looks like it's going to work well. Leaving room on either side for wires to go in. Bear that in mind. Now, if I do that, then I could actually fit the battery pack right on the board. And I could put the motor driver, I got voltage and ground over here, so I could put the motor driver, let's see, like that. Or here's another possibility. Let's move it all over to this side. The reason I'm going through all this is to get it in your head that you can play around on a perf board and really move things around to suit your needs before you ever solder anything in place. Kind of like I did last week there. Ha! So if I do that, and I put the battery pack right here, now I've got my leads coming out of the battery pack on the same side as where they go into the board. They go into the board here and there. But if I put it like that, well, let's see. Yeah, there's enough room there to put the wires in along that side on those holes. The other possibility with the battery pack would be to just stick it up here on the back of the sensor, and it keeps it off the board. If I ever want to add any other little boards later, you know, like maybe an accelerometer or something like that, or a wireless module, I've got room left on the board. So I could do that as well. Now if I did that, since the wires come out this end, we could go back over to this side of the board again and just put everything the way we had it a minute ago. So I think that's what I'm going to do. After all that messing around, there's the final configuration right there. We're going to put the battery pack on the back of the sensor, and we're going to put the microcontroller here. We're going to put the motor shield right there. We're going to stick a little LED right on the tail of this thing right there. And we are good to go. Maybe I'll move this forward one more notch. Yeah, like that. Leaves a little more room for the LED. Okay, time to solder some things up. Here I have some documentation on the A-Star 32U Micro, and if you read through this, you'll understand a little more how it all works. But what we're after on this particular application is the pulse width modulation outputs. What's pulse width modulation? Well, you can look up one of my videos on that if you just go to the Hack a Week website or right here on YouTube and just search for pulse width modulation. You will find my video or other ones that will explain how all that works. But basically, we have got, it says 7 pins run PWM off from this little controller, and there's a little square wave next to them on the print on the on the page, but on my particular one here I can only find 6, but it doesn't matter. I only need 4 for this application. So anyway, this is the sheet you want to print out for the A-Star 32U4 Micro and read through it. And there's also a user's guide. There's a little link here on this page. Of course, you have to click on it on the web page, not on the physical page. And you can get to the user's guide. Okay, enough of that. Let's go over to the DRV 8835 dual motor driver carrier. The pinouts on this can be configured in 2 different ways. There's one mode that's called in and another mode that's called phase enable. This is the phase enable mode where you can have a pulse width modulated signal coming out of right here, PWM, and that goes into the that's coming out of the microcontroller, and it goes into B enable, and that's your pulse width modulation. The B phase, whether it's high or low, will determine if the motor runs forward or backwards. That's one way to run it. Another way to run it is the in mode. This is the way we're going to work it. So what we'll do here is we'll have 4 pins coming out of the the 32U4 Micro, and it will drive this motor controller. But here's the deal. This is the truth table right here. So what we're going to do is basically with these 4 pins, if we want the robot to drive forward, we're going to drive 2 of them with a pulse modulated signal, and then we're going to drive 2 of them low. So in the code we'll write 2 pins go low, and then the other 2 pins will go a PWM signal at the speed that we prefer. Now to make it go backwards, we just reverse all of that. The ones that were pulse width modulated will go low. The ones that were low for the forward will now go pulse width modulated. That'll make the robot go backwards. So that's how we can control the motors. Okay, enough of that. Now we get on to the wiring. What I've drawn up here is just a basic schematic of how we're going to wire this up. So let's zoom in on that and talk about it. Zoom. Okay, so there we go. So this is the 32U4 Micro, heretofore known as the microcontroller. I'm getting really tired of saying 32U4 Micro. Microcontroller motor driver. Okay, that's what we're going to call it from now on. This is the microcontroller. These little squiggly lines represent the pulse width modulated outputs that it has available. So we're going to use 4 of them. We're going to use pins 3, 5, 6, and 9. And there is one motor, there's 2 motors, M1, M2. These are the outputs right here. 0201, 0201. Each one of those pairs will drive a motor. Now what we're going to do is take pins 3 and 5, that's this one, and they will run over here. They will drive motor 1. That's going to be the motor 1 control. So if we wanted that motor to spin in a particular direction, we would drive... Whoa, that was the transporter going off on my telephone. If we want the motor to drive in a particular direction, we will take, let's say for instance, pin 5, and we will run a pulse width modulated signal out of that into here, and then the pair that goes with it, which is 3, that one will be set up in the code to go low, and that will make the motor spin one way. If I want that motor to spin the other way, I'll write another line of code that will make pin 3 output a pulse width modulated signal, and pin 5 will go low. Get it? Want to go one way, pulse width this one, go low on this one. Want to go the other way, pulse width this one, go low on this one. So there's our basic wiring setup that we need to do. So let's start doing some wiring. So I'm all about salvaging stuff from other stuff. This came out of a computer power supply. It's some really nice, I guess, 24 gauge wire. And it comes in all kinds of colors. So it's nice for wiring up stuff like this on perf boards. It's just the right size. I've got red for a positive power supply, black Let's see, I need, what, 4 other wires. I want them to be different colors, so let's see what we got. We got gray, we got lavender, we got blue, we got green, yellow, orange, brown. There's all kinds of colors here. So salvage that stuff from other things, and you won't have to go sourcing out wire. All right, let's see. Let's get started here. So for my pulse width stuff, I think I will use green, blue, purple, and gray. So I'm going to cut those off. I'm going to reserve some of these other colors for other things later, like the sensor and other stuff. All we're going to do, really, in this video is get this thing wired up. Next video, we're going to start getting into the programming and the interface and all that stuff, because I still need to get caught up on how to set it all up with the Arduino IDE. So what I'm going to do here first is strip the ends of these 4 wires and leave a couple of millimeters of stripped wire poking out, and then we will tin those up. Let's get this guy out of the way. Get out the third hand tool here, and we're going to tin these up with a little bit of solder, depending on what part of the world you're in and who you want to get upset at mispronouncing it. And we'll do this to all 4 wires before we put them into the perf board. Okay, I've got my schematic laid out here. I've got my wires right here, and what I'm going to do is start soldering these in place, and as I do, I'm going to label them here, what color they are. That way I can keep track of them. I'll just label them right here next to the wire where I have some room to write. So we'll start out with pin 9, and we're going to put a purple one in there. So we'll poke that through the perf board. We'll come over here on the other side of the perf board, and we're going to take a tiny flat blade screwdriver and bend that wire over so that it stays in place. And then we will put a little bit of solder on there and just bridge it between that pin hole, that little terminal there, and the other one. We're just going to look for a little jumper of solder to go in there. See how neat that looks? Let me get up there and zoom in. Right there where I just soldered that one. That's all you want to do, just jumper that with a little glob of solder. Now let's see, that was pin 9, so we'll write on here purple. Now we'll move on to the next one, which is pin 6, and I choose green for pin 6. Push it through the hole and bend it over towards the microcontroller pin. Get a bit of solder on there. I'll tell you what I'm going to do. I'm going to pronounce it. Every other time I pronounce it, I'll say it a different way. So last time I said solder, so now I can say, okay, that's all soldered. Oh no, I've upset the dogs. There we go. All 4 of them are soldered up. Or did I say solder last time? I can't remember. Anyway, there you go. All soldered up. Now we can take these 4 and we'll run them over to the motor controller. There we go. It's all wired for control. Now we'll get the motors wired up. So we need to connect the motors now. So what I think I'll do is run some wires through the bottom of the perf board here, and then just take these tiny little motor wires and solder them right directly to the wires. Kind of limited on space and where I can poke these through, so that looks like the best solution to me. So we're going to just go with the schematic here. We're going to tin up a piece of blue wire, and we're going to run that. Let's see, we got the blue one here that goes right there. If we just go straight across to the corresponding pin on the other side of the motor controller board, that means it's going to be to motor number 1. So let's say that motor number 1, let's call that the left side motor. That's looking at the robot as if you were sitting in it, left and right. So M2 is the right motor, M1 is the left. So we'll take a purple wire, blue wire, and we're going to put that in, let's see, right here, the second pin up on the motor controller, which is 0, 1. And the same procedure, we're going to just poke it through there. We'll bend the wire over and solder it up. And then we will run it up to a spot right here by the motor where we can solder it in place and connect it to the motor wire. There we go. Those little wires right there are the ones that go from the motor driver through the board to right there, and now I need to put the motors back in place and solder them up to those wires. Okay, I'm going to put a little more solder tin on each one of these wires on the motor. Really tiny wires here. These things are skinny. And let's see, let's anchor this board in place with the third hand, like so. And then we're going to go ahead and leave the length on these wires that I have, just because a little extra length is good. If I need to pop it out and do anything to it, I've got some length there to work with. And it's about as simple as that. Doesn't take very much heat because everything is so tiny. There we go, that's one. And now we'll get the other one. And I've got them set up and wired all, I guess you would say, symmetrically, so that the red one goes toward the back of the bot. That way when I identify my pins, they're all going to kind of work out the same left and right. In other words, they'll be configured the same way for forwards and backwards when I do the call outs. Okay, let's clip them into place. Just like so. And all that wire that's just kind of hanging out there, we can just push down out of the way. Okay, that takes care of all of the wires between the controller and the motor driver, and the motor driver and the motors. Now we got to get some power from this battery pack that I moved over here, as you've probably noticed, instead of on the sensor. I just like it better there. It's a nice, neater package down low. So let's get that stuff going. What we've got going on here are two different kinds of power going on. One for the logic and one for the motors. And according to the data sheet on the motor driver, I can power the logic side of the motor driver from the power that comes out of the microcontroller. So on the microcontroller, I've got, let's see, I've got some outputs right here. They're over along this side. There's 3 volt outputs and 5 volt outputs. So I'm going to power up my motors right here, or my logic, I mean, right here, from the 5 volt out of the microcontroller. And then I'm going to power up the motor side of this motor driver directly from the battery. Over here on this side is where the power comes in. There's ground and voltage in, so I can take my battery leads and just route them right over here. I'm going to cut them off right about there, leave myself a tiny bit extra. We'll strip those wires back, tin them up, poke them through the holes, and solder them up. So now I'm going to take some red wire and jumper between my battery power, which is right there, and I'm going to go directly over to the motor power input on the motor driver with that same lead. Now we got to do a ground wire, so I can just jumper from my existing ground wire right over to ground here. I think I'll just do that on the underside of the board. It's going to be a lot easier. And there we go. Got a ground wire right there. Now we're going to take 5 volts out from the microcontroller right there. We're going to run it over here to VCC, which is the input for the logic. And the last one here, we got the logic power getting connected to the motor controller. I think that's it. There's the wiring diagram as it stands, all but a little crowded. I'll do a better version of this on the website soon at some point, but anyway, there it all is. The VN comes directly off from the battery. That is the voltage that powers the battery, or the motors. VCC is what comes off from the 5 volt output from the microcontroller. That's the logic voltage. And well, there it all is. All wired up on our little mini bot with its little battery case, and we're just about ready. Got the motors all wired up. There's our little LED there as a tail dragger. We'll wire that in later. We'll wire in the sensor later. For now, we're going to just leave it blank, because all we're going to do with this next time is write a very simple program to make it go forward, stop, go backwards, stop, go forwards, stop, backwards, etc. And then we might do a variation on that where we make it turn one way, turn the other way in place. Just to give you an idea of how the pulse width modulation works, how to interface with this little microcontroller. It's supposed to work in the Arduino IDE, and we will find out next time. So that's it for this week. We've got a little wired up robot now. It's looking more like a functional device all the time. I really like the idea of that LED back there. And a big thanks for the YouTube viewers that gave me the suggestions, especially for that little motor controller that takes up so much less space than the other one. That's awesome. This stuff is getting so teeny tiny. It's amazing. This takes up the space of a regular Arduino. I mean, let's see here. Here's an old Arduino Diezimilia. This is the first one I ever made a robot with, in one of the Rumble robots. Long ago and far away. Big old USB port there. And look at this. It's an entire robot in the same space as an original Arduino. Pretty cool stuff. Next time we'll get into the programming, learn about the IDE, the driver for this particular motor controller and microcontroller. There's a Windows driver available. I've got to do a little more research before I jump right into programming, but it programs in C in the Arduino IDE, and there's plenty of documentation for which pins will convert over to an Arduino program, an existing program. So if you have an existing Arduino program and you want to use this little microcontroller, you can refer to all that information on the Pololu website and be able to use it with an existing Arduino program. Pretty neat stuff. So that wraps it up for this week. Thanks for watching. Thanks for all of those wonderful donations, and until next time. Hey there, we are back. And we're back. The back.